It's the 26th of May, 2015, and this is episode 216. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future. Today's episode of Let's Talk Bitcoin is short and sweet. After episode 215's dive into the Case hardware wallet, we pivot from that $200 standalone device to a more affordable $40 take on the problem of moving security off of our multi-purpose computers and onto purpose-specific devices. Stay tuned for Saturday's episode 217 when I'll be joined by Stephanie and Andreas to dig into the controversial block size issue. We'll be joined by Bitcoin developers Gavin Andreessen and Peter Todd to hopefully understand the issue a little bit better. But that's Saturday's show. Today, we're talking Ledger Wallet. Here's LTB correspondent Matthew Zipkin now.
Hey, welcome to Let's Talk Bitcoin. This is Matthew Zipkin, and our guest today is Thomas Franz, who's the co-founder of Ledger Wallet. How are you doing today, Thomas?
Pretty good, thanks.
So the Ledger Wallet is an attempt at helping people to secure their Bitcoins. Why don't you tell us a little bit about how the Ledger Wallet works?
Yeah, exactly. Our vision is to provide cheap and very reliable security solution for Bitcoin. What we have developed, the Ledger Wallet Nano, is a first hardware wallet that is based on a smart card that has a USB form factor that you just plug in your USB port. It works with a Chrome app, and you can access your Bitcoin in a very easy and safe way. All the private keys are stored directly on the secure element on the smart card, and all the handling of the private keys, like derivation of the seed, the signatures, all that is made directly within the secure element. So everything that is on the browser that is potentially compromisable is just public information. Everything that is private stays on the secure element.
So when you get the Ledger Wallet Nano, what's the first thing you see? How do you use it and get it set up?
So yeah, basically you just buy it either from our resellers or our websites, $30, something around $30, shipping worldwide. You just receive your pack. It takes 2 or 3 days, and you just have to download a Chrome app that you get from our website, and you just plug it in your USB port. And after you just start the initialization process, you just choose a PIN code, choose it twice, and then it's going to pick up your seed. You will have the ability to write it down so that in case you lose your Ledger wallet or in case we just disappear, you can always restore your wallet out of any BIP39 compatible wallet. And boom, that's done. When it's initialized, the seed goes in the secure element, never goes out, and you're good to play. So you just put the Chrome app in, put your USB dongle in it, put your PIN code, and you've got access to your Bitcoin. So today it's a very simple wallet where you can send Bitcoin, receive Bitcoin.
Okay, cool. So is the entropy for the seed generated actually on the device?
No, it's not on the device, it's on the Chrome app using secure random, and then it goes on the secure element just afterwards.
Interesting. So the device is actually shipped no keys.
Exactly. Yeah. We are a hardware and software solution to keep Bitcoin safe, but we never hold a copy or whatever of the private keys of the user, for sure.
Okay, so the seed is communicated to the Ledger from the Chrome extension. How did you make that a secure process?
Yeah, today it needs to be done on a secure computer. That's the requirement today. You need to do it just is picked once and sent to the seed directly. And that's when you need to have the computer that is not compromised to be performing this operation.
Okay, so it's ideally an offline machine.
Ideally, yeah, you can do it. We've got very simple tutorial to have doing it with our air gap machine and all that. So it's pretty smooth to go. It could be better for sure. Having a screen directly on the device makes it more simple, but there's some ways to work around to do it. You can actually do it quite easily just following the tutorial.
I understand software a lot better than I understand hardware. So I don't know if you could possibly explain to me how, if somebody were to steal my ledger, how do you implement security in a hardware way?
On this point, to be honest, we have not invented anything. We've just been using like an industry standard that has been around for many, many years. Smart cards have been used to secure credit card transaction for like almost 25 years in France, Europe, and almost every country except the US. And actually, it's coming in the US by the end of the year. I think probably you receive your latest credit card with a smart card. And these smart cards are designed to keep secrets. So it's like a special architecture so that it is resistant to buffer attacks, to some power analysis attack and all that. So basically it's really like a hardware that has a special architecture so it can detect some vectors of attacks and it will just like wipe the information that is present in it. So it's really based on an industry like the banking industry. That's what you have like in passports as well. They've been using that kind of technology to secure like secrets, and we've been basically just bringing that technology for Bitcoin by designing like an OS that runs directly on a secure element and that can run Bitcoin primitives on the tamper-proof environment.
Okay, so the chip does the elliptic curve signature operations.
Exactly, yeah. We needed to redesign like a custom OS from scratch to be handling all these cryptographic operation that needs to be done. We've got like a strong tech team that is from that world, that comes from these R&D labs. Most of them are actually based in France, and they've been working around on Bitcoin OS for smart cards from scratch. Took us quite a long time, but now it can work on any kind of secured element. Our first integration was on the ST23, that is the smart card that you have like on the Ledger Wallet Nano, but it can be interoperable in any kind of secured environment, and we can talk a little bit more about that afterwards, but it really makes it portable on any kind of secured environment.
Interesting. So when you talk about an operating system, are there multiple components inside the ledger? Is there like a CPU and then that's attached to a secure storage element or something like that?
It's like a secure microcontroller. So on the very low details, I would recommend to see directly the spec of the ST23 to see exactly how it works. But yeah, basically it's like same thing as a computer, but like very, 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 very not powerful computer that works on tiny device. If you have a look on with a microscope on a smart card, you will see like just a little microcontroller on which you've got everything to make it work.
The Chrome extension is the part that actually connects to the Bitcoin network. Is that right?
Yeah, exactly. It's just like the client and the server is like the secure microcontroller on the smart card. Just there to build the transaction, to give like an overview of your account history, of the amount you have, to receive Bitcoin, send Bitcoin. So it's really like to connect to the Bitcoin network, yeah.
And does the Chrome extension connect to a Ledger server, or is it more of a decentralized SPV style?
Today we're using chain.com. Short term, we want to go on a SPV model on the Ledger and also on the mobile apps we will be doing. So today we're using Chain. More we're thinking about going SPV.
And does the hardware chip itself, will it just sign anything it's given, or does it?
I don't. When you sign a transaction, one could argue that the ledger is just an oracle and that you need like to have a screen and a button to validate the transaction. So we wanted to provide a cheap solution with that. So we found some workarounds to be able to have some validation that is made directly on the chip. Meaning that when I'm creating a transaction on the Chrome extension, it's going to ask me for some checks in the destination address and the amount with a security card that is uniquely paired to the Ledger Wallet Nano. So basically, I'm going to send, let's say, 1 Bitcoin to your address. It's going to check for like 4 random numbers of the destination address. I will make the validation with the security key, and the chip will be able to know that what you see is what is being signed. So if there was a man-in-the-middle attack, the chip could detect it. The second way we've been doing it is also to work with a paired mobile app that you can find on the iOS store and of Apple Store and Google Play, where you pair your Ledger Wallet Nano to the app using your security card, and every time you make a transaction, you will be pushed on your phone to see the summary of the transaction. So I will see that I'm sending 1 Bitcoin to your address. I press just validate on my iPhone or my Android, and it's going to send directly to the Ledger Wallet Nano the confirmation. It will be signed by the Ledger Wallet Nano. So we basically replace the screen and the button by an app that is on your phone.
I've seen pictures of the Ledger security card. It looks kind of like an old, like a decoder ring from a cereal box or something. It's sort of like a basic substitution code, right?
Yeah, exactly. It's paired uniquely to each device.
So that's an operation that happens at the factory then?
Yeah, well, in our premises when we put the firmware and the chip, yes.
Okay, interesting. So every ledger as it's being built is installed with a sort of a serial number that matches a printed security card, which comes with the product.
Exactly, and in the recovery card, you've got like a version to be redoing your security card if you need to do it, if you lose it or do it, yeah.
How does the security guard actually fit into the process? I know you just explained it, but I mean, when I'm actually signing a transaction, if I'm sending it to, an address that's like 1 ABC, does the Ledger wallet use that decoder to send me some characters back, or what do I actually see?
I'll just do one thing on my computer, and I will explain exactly the process I'm doing. So I'm just sending, let's say, 0.1 Bitcoin to an address, 1 FYS, whatever. I'm preparing the transaction. I'm going to validate the transaction with the security card. If I do it with the mobile app, it's going to send me a transaction, push notification on my iPhone, and I will see the confirmation of the transaction on the screen of my iPhone. I will just press OK, and the transaction will be signed.
It sounds a lot easier.
With the security card, you just create a transaction, and now it's going to ask me for random numbers of the destination address. So it's a capital K. So I have a look on my security card. It matched with letter 9. Then it asks me for like a capital P, matched with the number 6, blah, blah. I got 2 more. I'm going to put something wrong. And then I just press send, validate. And it's going to reject it right now because I put a wrong number in the last one. So basically here, the chip understood the transaction it has received is not the one that was seen on the screen. So it just automatically rejects the transaction.
I see. So the characters that it gives you for verification are from the destination address?
Yeah, exactly.
Can you send a transaction to multiple addresses?
Today we cannot. Today you just do it like to single address.
So right now, Ledger Wallet has one product, or there's 2 now, right?
So today there's the Ledger Wallet Nano that resells for $29, and you've got the Duo Edition that comes. It's a pack that comes with 2. That is $10 more, so about $39. We've also launched the Ledger Wallet HW1. So it's a same technology but with a different form factor, and which enables us to have a lower price point at just €15 with worldwide shipping. So yeah, we've got like the Nano, which comes in a fancy USB stick with a fancy box, and a hardware wallet 1, Ledger Wallet hardware wallet 1, that comes like on a different form factor, and that is a bit cheaper.
Okay, but it's the same chip.
It's the same chip, same technology, works exactly the same way, just a different form factor.
So the point of getting 2 of these is some type of multi-sig support, is that right?
The point is for backup, mainly. So when you set your seed initially, you can set the seed on multiple devices. So you can actually, let's say, put one in safe, give one to your wife, give one to somebody with exactly the same seed for, let's say, backup or disaster. And it's also possible to do some multi-sig. It's through partnership that we are doing. You can use like a multiple Ledger wallet to perform like whatever multi-sig scheme you wish.
Is that partnership with CoinKite?
Yeah, we just launched like a high-level API for third-party service providers to integrate like Ledger technology and new services. And the partnership with CoinKite is a great example of what we can do to leverage hardware wallets. And basically on CoinKite, you probably know CoinKite, a service wallet provider that lets you do some simple multi-signature scheme. We basically integrated directly with them. And when you create a wallet with them, you just, let's say, create N of them, or let's say a 2 of 2, and you can ask to have part of the key that is directly on the derivation path of the Ledger wallet. So in this way, you need to co-sign directly with the Ledger wallet. You could imagine signing with two Ledger wallets, and a transaction will be partly signed on both Ledger wallets and broadcasted through CoinKite services and using CoinKite interface to perform this transaction.
That's great. So you create the transaction with the CoinKite wallet, and then you use the same Chrome extension to get that transaction signed?
Exactly. I'm just going to do something where I'll do it live on my computer, and say I want to send some Bitcoin to this address. I want to send a certain amount of Bitcoin, and when I press send, it's going to ask me for. I need to go on the co-signing page, and I will sign one transaction with the Ledger Wallet Nano for part of the transaction on the Ledger Wallet Nano. When I press sign, it's just going to redirect me to the Chrome app directly, and it's going to just press confirm the signature, sign the transaction. It's going to sign directly, redirect me to CoinKite, and I will see that part of the signature is done, and then I co-sign, let's say, with CoinKite. So yeah, you build it on CoinKite, and the signature is made on the Chrome app. So yeah, it's really cool because you can work out on a multiple scheme very easily. You can do some 2 of 2, some 2 of 3. I think you can go up to 15 of 15. Well, it's a bit maybe a bit too much going to this level, but you can really leverage all the different schemes of multi-sig with that services. Yeah, it opens the possibility to have great added security on that. And moreover, it's like there's some for storing large amount of Bitcoin. Yeah.
So with a complicated multi-sig, like let's say you did a 15 out of 15 or something like that, the Ledger wallet doesn't actually care what the scheme is, right? It just knows it's supposed to sign one of its keys is involved, I see.
Yeah, exactly, yeah. A certain derivation path of the seed is used for this multi-sig scheme, and it's going to sign the transaction when requested.
Can you do all that fancy stuff from the Android app too, with CoinKite, for example?
Not yet. I'm not sure if the support is... No, it's not. The support is not made yet, no.
When you're using an Android, though, the Ledger plugs directly into the phone, or there's an adapter?
Yeah, there's an adapter. So today it's live with partners, and with Mycelium it's still in beta. With Greenbeats, Green Address, it's already live. You need actually an OTG cable, which is an on-the-go cable that you use, and you plug it in your Android phone.
Okay, but if you have your phone and your Ledger wallet, you can go out there in the world and spend Bitcoin, and you just plug the Ledger into your phone and type in your PIN to confirm each transaction.
Yeah, exactly. That's how it works. It's still not the ideal solution. Today, Ledger is mostly for desktop usage, for sure. For mobile, we've got like 2 things we're working on actively. The first one is the trusted execution environment integration, because as I said, our OS is very portable and adaptable to different kind of secured elements. So we've just partnered with Trustonic to be able to deploy our tech in the trusted execution environment of Android phones. So it leverages like the secure enclave of Android phone, so that when you are dealing with all the cryptographic operation and handling the private keys, you are actually doing all that on a trusted zone, and you also have a trusted UI where you can see the verification of the transaction and the confirmation of the transaction. For mobile device, it will be basically a virtualized version of the hardware wallet that you just download, and we've just provide APIs to other wallets to leverage that technology. And we've demoed it with Mycelium on the testnet, also with Greenbeats. So it's something that is really going to add a layer of security for Bitcoin Android wallets.
So the Ledger wallet, it's a hierarchical deterministic wallet, obviously, because it has a seed.
Exactly, yeah.
So I'm curious, does the master public key for that seed ever leave the device?
No, so everything actually stays directly on the secure element, and the derivation of the seed is made within the secure element, and it's only like the public addresses that are sent to query the blockchain.
And then I guess the Chrome extension determines how many new addresses it needs to query?
Exactly, yeah.
Okay, that's cool, because I know that that's a privacy concern. I've had a Trezor for a while, and I know when I connect it, it grabs the master public key and sends the entire master public key to the bits of proof server that they use for their API. And then another question I have is, so you mentioned that the seed isn't actually generated by the device, but does it have some source of entropy to generate R values for the signatures?
This one for the signature, actually, it's we are signing with K values with deterministic signature, where you don't need this entropy for the R value. So that's not the method we are using.
Gotcha. So it's a deterministic signature.
Signature, exactly. Yeah.
Yeah, because there have been problems with insecure wallets using bad R values, and so it seems like using a deterministic signature is a more secure way to go. So what's next for Ledger? I know I've seen on your website something called Ledger Blue. Is that still happening? Is that happening soon?
Yeah, exactly. So we want to be as lean as possible in the way in our development process. Ledger Wallet Nano was a single chip, very easy to manufacture, make it quite cheap on the market, and working in parallel on some broader version of Ledger Wallet that has a screen, that has some wireless capabilities, to be working on your iPhone with Bluetooth Low Energy, to be working in kind of in-person payment with NFC, and that has like a standalone that can validate transaction directly with a screen and button. So basically that's something we're targeting on the beginning of 2016. And yeah, that's the next big version we're actively working on. So it will be like a credit card form factor with wireless capabilities, a screen, button, and the Ledger OS within one of the secure element that will be on it.
That sounds great. How open source is your project? Can we see the firmware? Can we install our own firmware?
So we open source everything that we can open source. So the Chrome extension is absolutely open source. The Chrome apps, and the mobile apps also, API. But the only thing that we cannot open source because of the strict NDA is at least some aspect of the firmware. Because of the strict NDA we have like with the secure element company. So everything open source except everything where we are tied with NDAs with the chip manufacturers. Our idea in the midterm is to be able to have some dual chips where you've got some, let's say, a bit less secure elements to handle part of it, that where we could open source everything and run a fully open sourcing. But with this form factor, when you have a secure element, you don't have open source secure element as of today.
Is there a way to verify the ledger hasn't been tampered with when you receive it?
Yeah, well, that's one thing that is great actually with secure elements, is that you can make some attestation, meaning that there's a private key that's installed directly on the ledger in small batches of them during the manufacturing process. When you plug it in your Chrome app at the very beginning, it's just like verifying for the attestation. And if the attestation is not correct, then we're able to show the user that the firmware is not the official one and it has been tampered. So that's a beauty of the secure element. One other thing is we've got like a very, very detailed specification of what the Ledger wallet does. So just go on our GitHub, go on the specification of the OS. And one thing that is great about secure elements, it's running actually some tamper-proof code. So you can actually check against the specification what are the results that are given, and you can actually work this way to see what Ledger Wallet does and if it's doing it the way it is supposed to according to the specification. There's something that you cannot open source, but you can secure element, the fact that there are no randomness in the code, let's say. It acts against the specification. The specification is as detailed as possible, and anybody can check that it is acting against the specification. And that's something that will be also like auditing by third-party solution to be giving some extra certification of what our OS does.
This might be a bit of a tangent, but when you're designing a Chrome extension that interfaces with a piece of hardware, how is that accomplished? Because the extension is just JavaScript, right?
We basically leverage the Chrome HID protocol that has been live, was in Chrome 38 and beyond. I think it started sometimes in November. We launched in December, so it was just right at the right time that Google was pushing the standard. They are using it for their security key. I don't know if you've seen that, like for two-factor authentication on your Gmail or your Google account. You just plug in your like either YubiKey or a plug-up secure key. You plug it in your USB port and it makes the two-factor. It replaces a Google Authenticator. Thanks to this protocol, Chrome has native support of HID reading a smart card in a USB.
That's cool. So it's actually kind of a new thing, and Google's got some secure code to talk to the USB port.
Exactly, through HID protocol, which is an open standard used for like video aliens and things like that.
Cool. Well, Ledger sounds like a good way to secure some private keys.
Exactly. We're using like devices that are done solely for this purpose and do it effectively. That has been doing that effectively for years and can make it for very cheap and very it's something useful for the community for sure.
Yeah, definitely. Is there any kind of altcoin support?
No, basically it could be used with any altcoin that has some kind of BIP32 alt32 protocol, but we're not making the development ourselves. People want to do it. We've got like the entire spec to be working on their own support. That's not something we are as a team working on, but could be possible for others to work on it.
Cool. Why don't you tell us what the website is?
Ledgerwallet.com.
And lightning round question, 20 megabyte blocks, the end of Bitcoin or not? I'm just kidding. Thomas, thank you so much for your time. I wish you guys the best of luck, and thanks for joining us.
Thanks. It was a pleasure.
Thanks for listening to episode 216 of Let's Talk Bitcoin. Content for today's episode was provided by Thomas and Matthew. This episode was edited by Matthew Zipkin and Adam B. Levine. Music for this episode was provided by Jared Rubens. The magic word for this episode of Let's Talk Bitcoin is WARE. That's WARE. WARE. You've got until the 2nd of June to visit letstalkbitcoin.com or the Let's Talk Bitcoin iOS app to enter it for your share of the listener rewards. See you next time.